Good morning students. In the previous video session we have discussed about the integral calculus and average velocity, and today we are going to discuss about the relative velocity in one and two dimensional motion. So let us understand what is this relative velocity. You know that we have the practice of traveling by car, isn't it? So sometimes you know that Kanyakumari to Chennai, that road, bypass road is, NH road is what a very nice road to travel. Assume that you are going by car on that road. You can see that one car is overtaking you. While that car overtake you, you will see that that car is going, and you will think that that car is going more velocity than my car. So, this fact you are telling that while comparing your car velocity and his car velocity, suddenly while he overtake your car, maybe you will check your speedometer. Now you have seen that your car is moving with a velocity of 100 km per hour. So that time you will think, not only you, every person, our mind it will come that maybe that vehicle is moving with more than 110 km per hour. That's what he overtake. He has what overtake and he is moving forward. So this thinking is coming in our mind. And this thing only we are saying relative velocity. So what here we are doing means your car is moving. Assume that on that bypass road, your car, keep A, car A, you are moving on the same track. Another car B. He is going like this. Now you see two cars on the same track moving with a different velocity. Suddenly you will compare this car B velocity with respect to your car A. Isn't it? So that is the nature. When while traveling, when some vehicle overtake us, suddenly we will look our speedometer and we will check how much speed we are going. So that must be the speed he is going. Like that, on comparison is coming to our mind. That we can tell that it is what relative velocity. That is what the velocity of one object with respect to another object. So we are comparing the velocity of one vehicle with respect to what another vehicle. That is what relative velocity we can tell. And here one definition is there. When two objects A and B are moving with a different velocity, then the velocity of one object A with respect to another object B is called the relative velocity of A with respect to B. And this is just a definition. Now you can see some case 1, case 2, case 3. 3 cases are there. Let us see what are the cases. First case you see, consider two objects A and B moving with uniform velocity. Assume that two cars, the same example we can take. Now car A, car B moving with uniform velocity. This is what case 1. Case 1. Uniform velocity. This one velocity is VA and this one velocity is VB. Now you see both the car which is moving in the same direction. Now we are comparing VA and VB with respect to the ground. So this is also, you see, we are traveling on the road. Suddenly we can see that another car nearby us on the same track that is also moving with the same velocity. Suddenly we will compare, we will check the road whether we are moving with the same line or what we are moving forward or he is moving forward, like that, and all we will check up. And this is what one example. First case, consider two objects A and B moving with uniform velocities and along with the same track in the same direction. So this V and VB with respect to the ground. So what is the relative velocity? So the relative velocity of object A with respect to object B, we can write VAB is equal to VA minus VB. So this is what the velocity of car A and velocity of car B with respect to the ground we can write. This is the first case. So the same thing, this is the velocity of the car A with respect to car B. Now what is the velocity of the car B with respect to the object A? So V B minus V. So this is the first case. And now conclude this. How you can conclude this? If two objects are moving in the same direction, then what is the magnitude of this velocity of one object with respect to another object? Both are equal in difference in magnitude of two velocity. We know that you see here this case is, first case is what? Two cars moving with the same velocity VA and VB on a same track. Now we are comparing its relative velocity with respect to the ground. So we know that we are checking what velocity of car A, object A with respect to B. So both are moving uniform velocity, isn't it? VA is equal to VB only. So what we can write? VA minus VB. That is what here I wrote. Relative velocity of the object A with respect to B is VAB is equal to VA minus VB. The same thing, now we are comparing what? The relative velocity of the object B with respect to A. Now you see here what? Now also car moving with the uniform velocity on same track. So B is equal to what? VA only. So VB, take this side, VB minus VA you can take. So this is a thing we are writing here. This is the first case. Now what you can define this? Two objects are moving in the same direction. Two objects are moving in the same direction. The magnitude of what are the relative velocity of one object with respect to another object is what? Equal to the difference in magnitude of two velocity. This thing you have to write. Okay. So after this you can write this point. If two objects are moving in the same direction, the magnitude of relative velocity of one object with respect to another object is equal to the difference. You see the minus, no? So difference in magnitude of two velocity. Now let us see the second case. What is the second case? Case 2 is case 2. Assume that two objects which is moving in the uniform velocity but along in the same track only but in the opposite direction. Two object VA, its velocity it's two object moving with the uniform velocity, same velocity. So VA, velocity of object A, velocity of object B. Now both moving in the same track, but in the opposite direction. Now what you can write? The relative velocity of object A with respect to B. What you can write? VA moving this side. So VA minus VB is opposite to this. So minus VB. VA moving this direction, VB moving opposite to this. So minus VB. So that minus into minus plus. So VA plus VB. This is what the relative velocity of the object A with respect to B. VA plus VB. Now let us see what is the relative velocity of object B with respect to A. So B with respect to A means, you see, first VB moving opposite direction, so minus VB, then what minus VA positive, no? So VA. So this minus you take it commonly outside. So what will come? You can write minus. If you are taking outside, here plus will come, isn't it? So if you are taking this minus outside, here plus will come. So minus taken outside. So VB plus. You can write VA plus VB, isn't it? Here plus will come. So I am taking this one in the same manner. Now what you can define this, what you can conclude this means the same thing only, no? If two objects are moving you see two objects moving in the opposite direction but with a uniform velocity, no? The same velocity. So the relative velocity of one object with respect to another object is equal to the sum of the magnitude of their velocity. So we are adding the both the car velocity, we will get what the relative velocity of one object with respect to another object. Let us see what is next case. So you can take this conclusion, take a screenshot of this. If two objects are moving in opposite direction, then the magnitude of relative velocity of one object with respect to other is equal to the sum of the magnitude of their velocity. Now let us see what is the third case. Case 3. Let us see what is the third case. Okay. Now assume that two objects which is moving with the velocity VA and VB at an angle theta between their direction. Assume that one object is moving like this, another object is moving this direction. So it is making an angle theta. You can take VA, VB, VA, VB. Now you see, now what will be the relative velocity means? The relative velocity with respect of one object with respect to B, the same thing only, VA minus VB. Now both the relative velocity of object A with respect to the object B is VA minus VB, and BA also same thing only you will get. Now you have to find out the magnitude also, because here it is making an angle theta. Magnitude means we know that in triangle law of addition you have found R is equal to root of A square plus B square minus 2AB cos theta. This is what you have found in the triangle law of addition. Here also you have to apply the same. So here what you can do is VAB is equal to A means VA. So VA square plus B means VB, VB square minus 2 VA, VB cos theta. This is a magnitude and the direction of VAB. Now let us find the direction. This is a magnitude. Then you can find the angle also. Tan beta formula is what? There you have found, no? Tan alpha is equal to B sin theta A minus B cos theta. This is what you have found in the triangle law of addition. The same formula used here. So you can write tan beta. B means VB sin theta by A means VA minus B means VB cos theta. So now we need these two formula. First formula is what? First formula is VAB is equal to square root of VA square plus VB square minus 2VA VB cos theta. Now 3k is finished. Then now this third one, another 3 cases. In this case 3 we are giving value. The first case is theta equal to 0. Theta equal to 0 degree means what will be the direction? What will be the direction? Then the bodies move along parallel straight line in the same direction. Theta equal to 0 degree means both object A and object B moving in what? Straight line in the same direction. Now theta equal to 0. You see both A and B moving in the same direction in a straight line. So what we will get in this formula? Direction what we will get? Then VAB is equal to root of VA square plus VB square minus 2VA VB cos theta 0. Cos 0. We know that cos 0 is equal to 1. So VAB is equal to what we will get? VA square plus VB square minus 2VA VB into 1. So you will get VAB is equal to root of VA square plus VB square minus 2VA VB. This we can write what? This is in the form of A square plus B square minus 2AB. So A minus B the whole square. So root of VA minus VB the whole square. Now VAB is equal to what? VA minus VB. Square root cancel. So this is what? Direction. If theta is equal to 0. So in this formula we are putting theta equal to 0. We know that cos 0 equal to 1. So we will get VA square plus VB square minus 2VA VB. This is in the form of A minus B the whole square. So A square plus B square minus 2AB. So we are writing like this. Now the second, so this is what the relative velocity of the object A with respect to B. The same thing B with respect to A also we will get VB minus VA. Now second case, the second thing is Assume that when theta equal to 180 degree, theta equal to 180 degree, assume that the two bodies moving like this direction, opposite direction, parallel straight lines in the opposite direction. So the angle is theta equal to 180 degree. We know that cos theta is equal to 180 degree. So cos 180 will come what? Minus 1. Okay, this is A, this is B, moving in opposite direction. Now in this case, apply this in this formula. So what will come? VAB is equal to root of VA square plus VB square minus 2VA VB into minus 1. So we will get what? VAB is equal to VA square plus VB square minus into minus plus. So plus 2VA VB. So that what we can write? VAB is equal to VA plus VB the whole square, the whole root. You know that A square plus B square plus 2AB. So A plus B the whole square. Now square root and the square cancel. So VAB is equal to VA plus VB. The same, this is the relative velocity of the object A with respect to B. Then relative velocity of object B with respect to A is what will come? VB plus VA. Okay. Now last case is third case. Theta equal to 90 degree. So one object moving like this, another object moving like this, A, B. Now what will come? VAB? VAB is equal to square root of, you know that cos theta equal to 90 degree. So cos 90, so theta equal to 180 degree. So cos 180 is minus 1 here. Here what? Theta equal to 90 degree. Cos 90 degree is equal to what will come? 0. So in formula, VA square plus VB square minus 2VA VB into 0. So this whole term becomes 0. So VAB is equal to VA square plus VB square minus 0 will come. Root also there. So VAB is equal to root of VA square plus VB square. This is the last one. So my dear students, you can take a screenshot of this and study these cases also. Now based on this only, to example given rain, no? Rainy time, we are holding the umbrella, what in a theta degree only, not in straight line. So if you are holding the umbrella straight to our head, then what will happen? We will get a wet. Because rainfall vertically with velocity, but umbrella what we are using to avoid the rain. But what is happening? The relative velocity of the rain with respect to the person is here found VR minus VR. So the person will get a wet. So we have to hold the umbrella in this position. This is just example only, and go through this. Thank you all. See you all. Bye bye.